move me over here. And we'll go to the notes. That's the glorious calendar. So we're starting off by, when I like turning this so you can see the screen. We're kind of doing what we're doing there. But looking at the first one, and this is off of our concept. Factor first, factor again. Just remember the zeros of the numerator are the X-Intercepts. Boom, boom, and boom. So I'm going to go to the computer and actually mark those in a different color to really, timestamp this, what we're finding in order. Those are the X-Intercepts. Now, one that often is missed is that X. Usually, 4 comma 0 is easy and -2 comma 0 is easy. Then people forget about what does this X create? Well, X equals 0. So 0, 0 is another one. We can't forget that one right there. Right, then the next thing, zeros of the denominator. I divided out a -3, if you follow my sloppy work, and then factored. Zeros of the denominator end up being these vertical asymptotes. X equals 3. This is stuff that you should mark. X equals 3. And X equals -1 for X plus 1. And then real quick, I'm not going to go over this one, but it is a oblique or slant asymptote because the numerator is bigger than the denominator. You physically have to divide these two long division and get y equals -x/3 or -1/3 x. So that's this end behavior here, why it's slanted, because it's approaching the y equals -1/3 x line. All right, so that's why we see that behavior. For today's, then you go to the graphing calculator, you see this picture and you fit it all, okay? And then look at it. Here's what we're doing today. Now, this could officially be the start of your notes and call it 2.8, solving inequalities. So what I want to do is build off of what we already know into how this translates into our new concept, which really simplifies the matter. All right, so give them a minute to do that. Okay, so the first thing, oh, and I do have to get the calculator ready. Holy cow, what are our numbers in this class? And I didn't even take attendance. Oh, worst teacher ever. I knew it. I always say that. 15, 23, 23, but 23 is not even here. So we're going to go 2013. Second, I'm sorry you have to see this on the video, but this is how I pick my friends. My students. Are you guys my friends? All right. 22. Boom. Who's first? Nice. Ryan. No matter what, the calculator always seems to pick you. Okay. We'll get you in a minute. So we're going to use this graph. By the way, everyone, input, say it. Output. Okay, that's what graphs is. That's what you are seeing right now. You are seeing an infinite amount of input, outputs. Who's input? What letter? X. Nice. Super fast. So therefore, everyone, what's the output? Y. So you have to see by this graph, for instance, I wrote this in the other class too. I thought I still had it over there. I don't know what that is. Should get rid of that. For instance, let's look at just pick one in particular. And it looks like this is a nice one for -7. Ryan, yeah, yes, I will ask you this because that's what I asked last hour student. -7 comma what, or what's the output when I plug in -7 for x? It's the y coordinate. So what's the y coordinate that you see for -7? A relatively close. What does it look like? About 2. So Ryan, does that mean -7 should be a solution for x? Because I want x's that give me outputs greater than or equal to 0? True or false? Yes or no? True! -7 would be an answer because it gives me 2 for an output value when I plug in -7, and that is true. So therefore, it is a solution. That's what it means to be a solution. So I didn't really write that great for notes. I'm not going to write the substitution of -7 and all the x's and then evaluate it. The graph tells me that. Is that the only answer for this then, do you think? Yes or no? No. How many are there? Starts with an I. An infinite amount. Because aren't all of these output values positive? That means all of these input values are going to be good. All of these input values that I just marked right there will create an inequality that is true. Whatever the output value is, it's going to be positive. All right, and then what happens when I plug in -2 itself? What happens when I plug in -2? Ryan, what's -2 called? It's called an X-Intercept, but it's also called a
Mine's over there.
I know. I know. I'm trying to get him to What's a math word that starts with a Z? That's a very popular one. Is that a number line? Help him, everybody! Zero. Zero. All right. So -2 is a 0. So okay, what does that mean when I plug in -2 for X? The output is 0. Is this true or false? Is 0 greater than or equal to 0? True or false? True. Okay, so now this is going to lead to what my answer is going to be, what I have to write. Ooh, I got to breathe more. I could faint. All right, and here's some other problems, or problems, but other parts that are good for this. Right here, because this part's above. Little spots right here and right there, that part's above. That means that number that I plug in for X gives me a positive output Y. That means when I plug in that X over here, I get a positive number that's greater than 0 true, part of the solution set. This is how we answer these questions. Okay, so I'll do the first one. I think I picked on Ryan enough. Ooh, although 5th hour, the first person that I asked this, they were able to get the answer. Anyone think they could do that? Anyone want to volunteer? What is the solution set for X's? What are the inputs that give me positive outputs or 0 outputs? And that would be the answer. Anyone? Nobody? That's great. Okay, here we go. -infinity, this X, all the way up to what, everybody? Come on, somebody say it. -2. What do I put on -2? A bracket or a parenthesis? Bracket. I just went through that. It's a bracket because it is part of the solution set. It gives me a true scenario. Now, whoever's going next is going to have to do what I'm doing here. Union that with, what's the other little interval that works? Well, it's this little sliver right here. This little sliver of X's gives me positive output values for Y. So what is that? What are those between? Isn't it -1 and, anyone? 0. What should I have on -1? What do you think? Oh, there's a fight. Someone said parentheses, someone said bracket. Why is it a parenthesis? Parenthesis guy, tell me why. It's an asymptote. Here's what an asymptote would do for plugging it in. What would happen when you plug in that in? Why is it an asymptote? When you plug in -1, it gives me, starts with a U, undefined. When I plug in -1, I get undefined. I don't know why I'm changing colors arbitrarily. And this is not even a thing. Of course that is false, because you're not even getting a number when I plug in -1. So at asymptotes, you always have to have a parenthesis because it's never part of the solution set. It can't be. It's undefined. But what am I going to put at 0? What am I going to put at 0? Bracket, because it's a 0, and this happens. So it is part of the solution set. So see how I can keep going to this? Remember, this 2 is greater than or equal to 0 is back to Ryan's question about, hey, is -7 an answer? Yes. So that's, that was starting the ball rolling here. And then now I should be able to get somebody. How about that last interval? Here we go. 18, nice. Caesar. What's the last interval? And hopefully you can get parentheses and brackets right on this. Vertical asymptotes at 3, and then 4 is a 0. So go ahead.
3, 4.
And then what do you have on 3? What do you have on 4? Boom shakalaka. Last hour, 6-hour crew, this didn't go well. I couldn't get people to pick the parentheses or brackets right, even on the last example, after seeing it like 4 or 5 times. I was like, what is going on? All right. So let's get the next person. All right. 17, nice. Where am I looking? No matter what, I tried to, do a little different algorithm. I don't know. Calculator just loves you. Where am I looking now, above or below? Below. So now all I want you to do is name these intervals. Not the y intervals, the x's that make this happen. Okay, so go ahead. I'll put my fingers right here for the x's. It's these x's, real small interval there. If you have the question in front of you too, you can see your graph and then see where it's below and see. That's why I told you to get that worksheet out. You didn't get the worksheet out. Oh. Okay, I'll help you. This is -2 to -1 was where the 0 and the x-intercept was. So what do I write? So this x value, what is it? Make you say it. Oh no! Why is it a parenthesis? You never said -2 either, okay? So -2. All right, that's the start of it. Why is it a parenthesis? It's starts with a z. 0. So when I plug in -2, I get 0 is less than 0. Is that true or false? That is false. When I lose that equal part, the zeros no longer become parts of the solution. So therefore, it's a parenthesis. -2 to what? There you go. What do I put on -1? Parenthesis y? Asymptotes never. Got it? Perfect. Next interval from here to here. Let's go. Make sure we're taking the notes too so we can follow along and know where those points are. Okay, so what's that point? 0 to what? It's not negative, it's over here to the right, so it's what? 3. And I think you get at this point, all of these are going to be what? Parentheses, because the zeros don't work anymore and asymptotes never work. What's the last part? 4. You got it. Okay? Don't you feel alive? Calculator picking you today? Oh, that's why I love it. Come on, pick 14. Let's go. Dang it. All right. He's not here. We have another chance. Oh, she's not here. This is interesting. Oh, sorry, Colin. Gonna yell at those absent people. All right. By the way, I do have to take attendance. Okay, we're going right to it, Colin. I'll help you out on this though. But remember this, well, in case your number comes up again. And anyone else in here knowing how to graph these. This is number 2, my first set of notes that I did. I did this one for you. But now we're going to solve inequalities with it. Remember, the zeros of the numerator, x-intercepts. Zeros of the denominator, vertical asymptotes. Right? Horizontal asymptote. These are equal in degree. So it's y equals -1/4. Remembering all these rules that are coming up here. And I think I have all that part. You know what I really want to do, though, is mark that 1, 0. It's up to you to know these. Above, obviously below, but then it may not be so obvious that this is below. See, it skips below that x-intercept, but then gets controlled by that really, really tiny y equals -1/4 asymptote. All of that graph is below the x-axis. Just very, very small numbers. All right, Colin, what am I looking for on this first inequality up here? This one right here. Am I looking for the yellow graph or the green graph? Yellow. It's a very simple concept. All right. What's the interval that makes this true, this inequality, based off of my last 2 examples? Awesome. Yep. And what do you got on that? Parenthesis or bracket? A what? Bracket. Oh. Why is it a parenthesis? When I plug in 1, I get 0 as an output value. True or false? 0 greater than 0. True or false? False. Okay, so that's okay, on our new thing there, but that's hopefully me calling on you, right? It ingrains that idea into your brain that this has to be a parenthesis because that's not true. Never true. Could be true if there was an equal sign, but there isn't. Okay, good. Who's next? With this class, I think everyone's going to get to go. 20. Is that a repeat? It's a repeated absent person. Wish I could have omit. Come on, you know what? Now you're doing this on purpose. 14. Yes! All right. Sorry. I just think you enjoy being here. All right. So what's the answer? Are we looking for yellow or green? Green. Okay. All right. So what do we got for answers? This is so much fun. Got it. Nice. What do I put, a parenthesis or a bracket? I'm waiting. Oh. Why is it a parenthesis? It is an asymptote. So when I plug in -3, I'm getting undefined here. Undefined is not less than or equal to 0. That's a false because it's not even a thing. It doesn't even evaluate. Union that with. Go ahead. Don't you feel alive right now? Good. Hearts pump, ba-boom, ba-boom, ba-boom. Get all excited. One. What do we put on 1? It's because when I plug in 1, I get 0, and that is true. Keep going. And beyond. Oh, never mind. That's just from a movie. Do you know that movie or no? Yes, good. You got it right. All right, we won't do that one. Oh, now we're going to get to this. Okay, well, those are ones that we already graphed. Now, I'm going to solve this inequality by graphing. But you know what I'm going to do? And the other math teachers kind of said they're going to do this. And then I feel like I'm forced to show you. And then I'm never going to do it again. But it is back in the day, if you didn't have a graphing calculator, you could actually solve this without having to draw the picture. So there is a value to it. And I think back in the day, we would have non-graphing calculator tests. And I guess it is kind of good because some people don't bring their graphing calculator. Then you'll have to do a sign chart. So I'm going to do this 2 ways. But let's get my student here. 17 again. Oh, that's 3 times, isn't it, Ryan? All right, what's the X-Intercept? Okay, this is what happened last hour. I couldn't get anyone that still will tell me these things, and I'm not saying this happened with Ryan. So do you know what the X-Intercept is, or you need help? Not, yeah, then you solve for X, but we got to get to the fast thing. It's the 0 of the numerator. -2, comma. All right, and then we'll graph that later. What are the vertical asymptotes? I was going to really shorten it up. What are the vertical asymptotes? Those are the zeros of the denominator, or solving for the zeros of the denominator. All right, I'm going to mark you wrong on that. So I'll say plus or minus 3. What do you have to say? What's the format for that? There you go. That's what I need. If you don't write that, I got to mark a ½ point off. And some people will say plus or minus 3, 0, and that's completely wrong. It's got to be an equation of a vertical line. Hey, and just for giggles, just so I can get a nice picture of this, what's the horizontal asymptotes? Or asymptote, there's only one. I said that inappropriately. If you look up here, Ryan, the degree of the numerator is smaller than the denominator. That's the default one. What is that? I'll mark you wrong. There you go. He said 0, but not saying why means he might write it. And others do the same thing. It's the most common error that people do. Okay, real quick, Ryan. You know what? Just for time, I'm going to go to my graphing calculator, look at the picture, and have it fit this. For time, this is what happens. The picture looks like this. I have -2, 0. I have -3 for an asymptote x equals, of course. Just said that to him. You got to say x equals. X equals. And then y equals 0 for time purposes, graphing calculator, we go to it, we see this. It's down here. Yes, a horizontal asymptote can be crossed. It's an end behavior asymptote, not what happens in the middle. So a horizontal, some people ask me, wait, you crossed that. That's illegal. And it's not necessarily. It's actually okay. And then I just forgot. I have to wear a math shirt next week. Maybe I'll wear it Wednesday. You shall not pass. Anyone know what that's from? You shall not pass. You know? Lord of the Rings. I have a shirt, but it's a math shirt, and there's an asymptote, and it's got Gandalf on it. Never mind. Here's a sign chart. This is ridiculous. It's not ridiculous. It's good. I just didn't want to really teach it because of our time, but I think we do have time. Student number 13. You ready? It does the same thing as the graph. So here's what you do with the sign chart. Oh, and I really didn't establish this. Let's look up at original things. Do you realize that it's the X-Intercepts where the graph changes from above to below? Right. And also the vertical asymptotes. Look at this. The graph over here is down here. Then when I flip to the other side, now it's up there. So the critical values are the X-intercepts and the vertical asymptotes. Horizontal asymptotes, it helps with the shape of the graph, but it doesn't apply to how to do this with the sign chart. So -2 is a 0, -3 is a vertical asymptote, and 3 is a vertical asymptote. And then this is what you do. You test points, but you don't go all the way. So you don't need a calculator. So you test -4. Now, Colin, don't give me the number. When I plug in -4, what do I get on the top, a positive or a negative? That's all we do. So you can probably get the number. It's -2. We're just doing a sign analysis to see input. Do I get an output that solves this inequality? What's -4 squared, just real quick? It's just 16. 16 minus 9, positive or negative? 16 minus 9, positive or negative? Huh? Positive. Don't do the evaluation. All right? Now, what's a negative divided by positive? A negative or a positive? So, would that solve? Would -4 be a solution for this? Yes or no? Oh. Negatives are what compared to 0? Less than 0. So through this analysis, I just proved -4 would work. That means any of these numbers would work. Hey, Colin, look at the graph. Didn't the graph tell me the same thing? Look at it. It's down there. That's why these do the same thing. All right, let's keep going with the sign chart, Colin. Oh, man, just so that I say I did cover it so the militant math teachers say, did you do that or not? Hey, what's -2.5 plus 2? Positive or negative? It is negative. Now, be careful on this next one. This is how you think about this, because I know people freak out about decimals. Isn't 3 squared 9? 3 squared is 9, right?
Oh, yeah, 3 squared is 9. Yeah.
So 2.5 squared is smaller or bigger?
Smaller.
Smaller minus 9 means what kind of number? Positive or negative? Negative. What's a negative divided by a negative? That means this doesn't work, because a positive is not less than 0. 0 is a good number to check. Positive or negative? Positive or negative? Positive over negative is a negative. True or false then? True. This would be good. Hey, doesn't the graph say the same thing down here? And then you'll see what 4 gives us. 4 gives me positive, which is not good. So I'm not saying it's bad. It's just, in our time, I'm not doing both ways for the rest of the, rest of this time here. We got the answers from the graph. All right, good job, Colin. There, I showed you it. 15, nice. Beatrice, what is the solution set now? And be careful with brackets and parentheses, so on and so forth. Negative, what's that? Negative infinity, right? Okay, 2. Bracket or parenthesis? Nice. Why? Starts with an A. Asymptote, which means it's undefined. Continue. And then what do we put on -2? Oh. Why is it a bracket? What is -2 called? So when I plug in -2, I get 0 is less than or equal to 0, which is true. And then to what? And I don't care if you guys hate being called on. I can see the brain, like and you're actually burning this in as we make these mistakes, and then I'm able to correct it. And okay, and then you solidify it more. I don't care. I think it's the greatest thing ever. Makes you a little uncomfortable. It's fine. That's part of the process that we need to go through. Awesome. Ooh, 19. I feel like that's a new one. It is you. Nice. How's your brother doing, by the way?
He's doing good.
I already forgot his number. Was he 18? Did you miss by 1? Okay, we're not doing a sign chart. So, and I didn't say this to the other classes, but if it says do a sign chart on the test next week, ignore it. Just do give me a sketch and then analyze from the sketch. Okay? All right. Now, this is interesting. I've been doing this for people. Do you know how the numerator factors? This often stumbles the students. They don't look for this first, and you should always look for this first.
GCF?
Yeah, see how they don't. See how you didn't either? You're like, ooh. And then they don't do GCF factoring correctly. What about the bottom? That's a little bit more forward. MA.
-3, -5.
So what does that mean?
X asymptotes.
Well, just factor.
-3.
Okay.
And -5.
Well, X minus 5, right? That's what I wanted you to write or say. Because you got the numbers, now you got to put them in the factored form because that is the unfoiling of it. And then it looked like you wanted to go ahead. So why don't you go ahead and tell me what the X-intercepts are?
Intercepts?
Yeah, let's flip it.
0 and -1.
Oh, you're going to get marked wrong so quick. 0, 0, -1, 0. And I say that so that you don't get marked wrong on the actual time that we get a test here. What's a vertical asymptotes? Vertical assay.
That'll be x equals 3 and x equals 5.
X equals 3, x equals 5. And then just for giggles, what's the horizontal asymptote so I can get a picture here? This one I will go to the graphing calculator. I'm going to cheat. I have last hours already on there. You have these equal, so it's that special rule. I'm just going to start with the y equals. If you don't put y equals on your test, you're gone. You know?
I do not know.
When these are equal, it's the coefficients in front.
1.
1 over 1, which is 1. All right, I didn't draw anything. So here we go. 0, 0, -1, 0. And then we're way over here. 1, 2, 3. And we got a real big trick on this one. And I'm sure you know how to type it in the calculator. So I'm glad I got this ready already so I don't have to, on YouTube, this YouTube video that will be, have to wait for it. Y equals, we already got it. And then I'm going to zoom standard because that's where you'd probably start normally. I'm in the way of the graph a little bit, but that's all right. Takes forever on my slow computer. And then, this is why you needed to know that the X-intercepts are there. Because here it is. It's up here. Then there's that X-intercept. So actually right now it hit the X-intercept and it's below. And then it hits this X-intercept and it's back above. But I'm going to obnoxiously write that like that so I really don't make a mistake. It doesn't just go right through and stay on the X-intercept between -1 and 0. It's very important for this. Then another thing, X equals 3, and then 4, 5, X equals 5. That's controlling this graph and this graph. There's something in between. And I got to find it. This makes this a CAT question, not so much a Math 3 question. CAT students have to know something is missing, so they have to go to their window, and it probably is below. But if you searched above as well, I guess that could potentially happen in a real special case. But I just extended my y-axis a little below to -50, and now here it is. So that graph just was off the window. And I think you know about windows and know that that's a possibility. So here's how I'm going to sketch this for the next person that's going to answer this. Sorry, I forgot y equals 1. See, that's why I wanted to know that's there. So I know that this graph is doing this. Then it's going like this. That is not what I saw in the picture, but I want me to know that. I want me that has to be the behavior for two X-intercepts that are so close. And then we had this part here, which didn't really matter to this one, and this part here. Okay, who am I looking for? Student number. This is so you know I'm not being personal here. 13, that's the third time, I think. Above or below? Says greater than 0. So I think you're flipping that around. Don't flip that around on the test, okay? And then let's get this over with. Are there any brackets at all? No, someone said that last hour. He goes, first of all, they're all parentheses before he had to do the, I go, that's awesome, you're right. Asymptotes never, zeros won't be because there's no equal to. All right, so go ahead and tell me the interval where the x is. Good. Me? Oh. So to -1.
0, then what is that? 3.
Yep. And then union that with what? Awesome. So make sure you get those things in your head. I think you're getting the inequalities flipped in your head, and that will reverse the answers completely. You write all the wrong answers instead of the right ones. Now, I was thinking about not doing this one, but I do kind of like it, because really what this is what check it. Ah! Okay. Sorry, I thought I had the schedule there. 109, right? We're doing fantabulous. Let me go back to that. Okay. All right. Is that a rational function? Yes or no? Does that have asymptotes? Yes or no? Can anyone answer any questions? Yes or no? No one said a word. This is not a rational function. Okay, this is actually our polynomial time now. Okay, so the next person I'm going to ask, we're going to go back to sections 2.1 to 2.3, maybe a little 2.4, 2.5 as well. All right, but this was in 2.3. You know, this little situation here. All right, let's get a student. I think we'll give 13 a break if he gets hit again here. Holy smokes. That's a new one. Caesar, nice. All right, first thing I'm going to ask you is, what are the X-intercepts for this picture? Nice. He's on fire, ready to go. No. All right, and that's good, and I like how you were questioning it. When you find zeros, don't you do this? You set it equal to 0 and solve. What kind of number do you get for that? Yeah, you're right, actually. Good. So -1, and then when you square root, it actually 100% is I, right? Because the square root of -1 is I. Does that mean an X-intercept for a real graph on a real coordinate plane? No. What's another X-intercept?
4.
Good. Nice. Do you remember what happens with the graph there? Nice. This is awesome. It bounces. Okay, so I'm going to bother you for a few more questions, and you're off the hook. If I were to multiply this out, what would the leading coefficient be, and what would the power be? So what I'm saying, obviously, if I took the first two parentheses, it'd be x cubed, right? But then I multiplied this and I got them all together, what would I end up with? What would be the highest degree?
1.
Oh, no. No, meaning we'll at least have x to the third, then 5. And then what would the leading coefficient be? 1. Okay, I got you. Your 1 was the leading coefficient. Got it. Last question, you're like, leave me alone. Come on. The graph, would it look like, oh, I got to get myself in the video. The graph, would the end behavior be like this? A, I think I'm reversed on that picture, though, what you have to see. A, B, C, or D? It's A. And even though I was reversed on the camera, I think you saw that in reverse. This is what Caesar saw. He's right. Because now what we're going to do is, without even touching the graphing calculator, zero analysis, expectation of picture, put it all together, and then we can answer when will this f of x be 0, positive, and negative, which is analyzing or answering greater than 0, less than 0 questions. All right. So you said it had to be a bouncer and it's got to end up. So the only way that could happen is like this. That's it. That's how it has to end. So that's how I start this picture. And then that imaginary 0, well, just with all that extra power, there might be some little waves in there, but it's definitely going to end like that. What it's going to look like in the middle doesn't matter. It's going to be above. All right. So let's get another student. Caesar did a lot there and did it pretty efficiently and fast. Nice. Oh, she looks so excited. Okay. A, what are the zeros? This is just a couple answers, hint, hint. Good. Now, and last hour, the girl goes, and plus or minus I. I'm like, holy cow, that's great, but it doesn't, solve the inequality, so that was awesome. Very good. B, where's a positive? Where am I looking for, above or below? So be careful on this. It's all of this, and then stop, because it says where it's positive. And then it continues with that. So what's that X interval? And notice what I'm putting. I'm going right to parentheses. Go ahead. This is awesome. This is working out great. I really hope that this doesn't seem too bad, because solving inequalities really isn't. Let's do the last one. And then notice on these I put parentheses because it said specifically only where it's negative, not 0. So we have to exclude -3 at the end. So it's like we're solving when this is less than 0 on the last one. Less than 0 that's the solution set for less than 0. Okay, if we did that. All right, good. Now you don't have to write this down. Don't. Just write the example. Just say solve. But see how this says example 1 and 2? Because I reversed the notes compared to the other CAT teachers. I wanted to do the rationals first because we just graph rationals, and then go back to polynomials and what we know about those. So since the polynomial is less than or equal to 0, we need zeros and everywhere where the polynomial is less than that. So just write the question and say we're going to do it. Just going to solve it. Nice. What are the X-intercepts? Nice, real fast. Last hour I was like, ooh, I don't like fractions. Man. And then, here we go again. It's probably reversed. A, I think I am going to be reversed. B, C, or D. I just seen how I looked in the picture. It's A again. Ooh, one more question. What's the leading coefficient and what's the power? Let's do the power first. It'd be x to the what if we multiplied it out? Because I went out of order there. That's why you knew. Well, then what's the leading coefficient? Yeah. Okay, so that means it would be what you said there. So I did that out of order. All right, then I can't ask you anything more because this is what you'd have to do. All right, this is what the picture would look like. See how fast these are? And then where am I looking for, above or below? Yeah, keep going. You know what? No, you're showing like you're there. Okay, yeah, you go ahead. You. That's hilarious. The calculator rules, man. I can't go against what they do. So where am I looking, above or below? So there. Oh, below. Outputs that are less than 0 or equal to. Okay, go. What's the solution set? And then what do I put for that? Nice. Sixth hour yesterday. It's going a lot better 6th hour today. Because even at this point, people were like, parentheses, right? They were saying all the wrong numbers. I don't know what was going on. It was freaking me out, man. Anyone have any questions? Okay, then the last example of the day. What did we say? What time are we getting out? I did go to the thing. 09? We're great. What do you need to do on this? It's actually kind of sneaking up here on you. I don't have any zeros, so what do I have to do? It's right down here. What do you get? What do you do? Where do you go? Graphing. calculator. It's going to speed things up. So you get this one, you're like, uh-oh, I got to synthetically divide. So I will, because the zeros don't look perfect. And I guarantee we're going to have questions where the zeros are going to be like right here and you're not going to know. But you'll know one of them. Like, what's that one right there? What's that one right there? -2. I'm going to prove it. Because one of the other zeros is a fraction or a decimal. 2, -2, -4, -11, 22, 12, -24, 0, hike. Perfect. Now, I do have time for this. Let's get somebody different. Is that new? So who hasn't gone yet? What? The calculator, Natalie, seems to like always avoid you. And then you're the only one. Should we make her go? Let's do it. Now watch, Natalie. What's this look like? What number does that look like right there?
4.
What does that mean as a factor? If 4 is a 0, what's the factor? Like if 4 is a 0, then it's... See, here's what I'm doing. I'm actually helping you factor this. Because I already took out that -2, which would be x plus 2. And now that that's out, I can factor this depressed polynomial. Now here we go. This drives me nuts. Still, people to this day don't know that foiling and factoring are related. Okay? What, Natalie, times x equals 2x squared? 2x goes in here, and then we'll check ourselves before we, anyone? Wreck ourselves. Is that not a saying anymore? Anyway, what times -4 equals +12? That should go in there. And then check ourselves before we wreck ourselves. We're bringing that back, man. -8x and -3x is -11x in the middle. I know I'm good. So what you should know, Natalie, is that this is 3/2 specifically, and then you already said that this is 4. What am I looking for, above or below outputs? Above or below? Above. Now it's time for the answer. What is the answer for the x's? The x's are 2. I'm going to wait for that magic answer unless you want to tell me.
No, it's
I didn't like how you're like, so which one is it? All right, take a pick. Take a pick. Focus on this. Which one is it? Parentheses or brackets? Oh! Why is it parentheses? Because when I plug in -2, that's a 0. Is 0 greater than 0? True or false? False. So it can't be part of the solution set. That's why it's a parenthesis. Give me the last interval.
union, parentheses,
Yes?
3/2.
Oh, no.
Right? No. Oh, it's,
So here to here.
No, yeah, and then 4 to calculation.
4 to infinity. Got it. All right. Everyone participated today. Nice. In my class of 2, 4, 6, 8. Who do we appreciate? All righty. We'll end the video now. I think I can. There it is.